Ever wondered what makes your electric fan spin, or what's really happening inside when you flip that switch on a hot summer day? It's easy to take for granted, but behind that simple motion is a fascinating story of science and invention. Or how an electric car glides so quietly down the street, almost as if it's floating. The secret lies in a remarkable piece of technology that's become essential to our modern world. The answer: the electric motor. These ingenious machines are everywhere, quietly powering our world from behind the scenes. From the smallest gadgets to the largest industrial machines, electric motors are the unsung heroes of our daily lives. But electric motors didn't just appear overnight. Their development is a tale of curiosity, experimentation, and breakthrough discoveries that changed the course of history. Their story began in the early 1800s, when scientists first started to explore the mysterious link between electricity and magnetism. This was a time of great scientific excitement and possibility. In 1820, Danish physicist Hans Christian Ørsted made a groundbreaking observation. He noticed a compass needle jump when he turned on an electric current nearby, proving for the first time that electricity could create a magnetic field. This simple experiment opened the door to a new world of scientific exploration. This discovery electrified the scientific community. Suddenly, inventors and researchers everywhere were eager to unlock the secrets of electromagnetism. Michael Faraday, a brilliant English scientist, soon built on Ørsted's work. In 1821, he invented the first simple electric motor, a wire spinning around a magnet, demonstrating that electrical energy could be transformed into motion. Early motors were weak and mostly experimental, more like scientific curiosities than practical machines. But they proved a crucial point: electricity could be harnessed to do real work. These early devices showed that electrical energy could be turned into motion, mechanical energy, a revolutionary idea that would soon transform industries and daily life. Inventors like Thomas Davenport in America and Nikola Tesla in Europe took these concepts further, improving motors and making them stronger, more reliable, and more efficient. By the late 1800s, electric motors were powering factories, driving streetcars through bustling cities, and even beginning to appear in people's homes, changing the way people lived and worked. Imagine life without them. No refrigerators to keep food fresh, no washing machines to lighten the load, no blenders to whip up a smoothie. Our modern comforts depend on these silent workhorses. The journey from a twitching compass needle to today's powerful, efficient motors is a testament to human curiosity and ingenuity. It shows how one small discovery can ripple out and change the world in ways no one could have imagined. And the story of electric motors is still being written. Engineers and scientists continue to push the boundaries, making motors smaller, smarter, and more powerful than ever before. Every new innovation builds on the curiosity and creativity of those early pioneers, reminding us that progress is a never-ending journey. Electric motors are a perfect example of science in action, shaping our lives every day, and their spark of history continues to power our future. Electric motors come in many types, each with a special job. Just like members of a team, each one brings something unique to the table. You can think of them as a family with unique talents, each suited for a different task in our daily lives. The two main branches are AC motors and DC motors, and understanding the difference is key to knowing how our devices work. DC, or direct current, flows in one direction, like water down a river, always moving steadily from one point to another. Batteries power DC motors, so you'll find them in remote-controlled cars, cordless drills, and phone vibrators. These motors are everywhere in portable electronics. DC motors are simple, reliable, and perfect for small, portable devices. Their straightforward design makes them easy to control and maintain, which is why they're so popular in gadgets you use every day. AC, or alternating current, is the electricity from your wall outlet. Unlike DC, it changes direction rapidly, pulsing back and forth many times per second. AC motors run big appliances, washing machines, refrigerators, and other household essentials that need a lot of power to operate smoothly. They're also the muscle behind industrial fans and heavy machinery, chosen for their strength, efficiency, and ability to handle tough jobs. There's also the brushless DC motor, or BLDC, a high-tech cousin in the motor family. It's super efficient, using electronics instead of brushes to switch current. BLDC motors are quiet, long-lasting, and found in cutting-edge technology like drones, computer hard drives, and electric vehicles, where precision and durability matter most. Each motor type has its own strengths and weaknesses, so engineers carefully select the right one for each application, matching the motor's abilities to the job's demands. Whether it's spinning a tiny propeller on a toy drone, or powering a massive subway train carrying thousands of people every day, there's a motor designed specifically for that purpose, tailored to fit the needs of the device. The incredible variety of motors is what makes modern technology possible, powering everything from the smallest gadgets to the largest machines. Next time you use a gadget, take a moment to appreciate the motor family working quietly inside, making your life easier and more connected. Electric motors are everywhere, quietly powering our world and making life smoother, more efficient, and full of possibilities. Peek inside an electric motor and you'll see a fascinating puzzle of wires, magnets, and metal parts all packed tightly together. At first glance, it might look complicated, almost like a mysterious machine from a sci-fi movie. But if you break it down, you'll find that the inner workings of a motor are actually quite logical and beautifully organized. In fact, building a motor is simpler than it seems. Think of it like snapping together Lego bricks, where each piece has a specific job and fits perfectly with the others. The main building blocks are the stator, the rotor, the axle, and, in many DC motors, a clever part called the commutator. Each of these components plays a unique and essential role in making the motor work. The stator is the stationary outer shell of the motor. It holds either permanent magnets or coils of wire, and its job is to create a steady magnetic field that surrounds the moving parts inside. Inside the stator sits the rotor, which is the part that spins. The rotor is attached to a shaft, and this shaft is what connects the motor to the device or machine it powers, turning electrical energy into useful movement. The real magic happens in the interaction between the stator and the rotor. As the magnetic fields from the stator and the rotor interact, they create forces that set the rotor spinning. Wrapped around the core of the rotor or stator are windings, long coils of copper wire. When electricity flows through these windings, they transform into electromagnets, generating powerful magnetic fields on demand. Unlike regular magnets, electromagnets are only magnetic when powered. This means we can control exactly when and how the motor moves, simply by turning the electricity on or off. In DC motors, the commutator acts as a smart switch. It reverses the direction of the current in the windings at just the right moment, keeping the motor spinning in the same direction. Brushes, made of carbon or metal, press against the commutator. They deliver electricity to the spinning rotor and flip the flow of current at exactly the right time, like a conductor leading an orchestra. This clever teamwork keeps the rotor spinning smoothly and continuously in one direction, turning electrical energy into steady, reliable motion. Without the commutator, the rotor would quickly get stuck, unable to keep turning, and the motor would stop working altogether. All these parts, stator, rotor, windings, commutator, and brushes, work together in perfect harmony, transforming invisible electricity into the powerful motion that drives our world. Let's zoom in on the stator, the strong, silent partner of the electric motor. The stator forms the outer frame and creates the magnetic field that makes the rotor spin. In simple DC motors, the stator uses powerful permanent magnets, always ready to interact with the rotor. In bigger motors, especially AC types, the stator uses coils of wire, electromagnets powered by AC electricity. As the current alternates, the magnetic poles flip rapidly, creating a rotating magnetic field. This wave of magnetism drags the rotor along, causing it to spin. The stator's design, number of coils, winding pattern, and core material is carefully engineered for maximum efficiency. Though it never moves, the stator is the powerhouse that sets everything in motion. Without it, the motor's dance would never begin. Now meet the rotor, the spinning superstar. The rotor's job is to turn magnetic forces into real movement. It's mounted on a central shaft and spins at high speed, doing the motor's work. In DC motors, the rotor, or armature, is made of wire coils around a metal core, becoming an electromagnet when powered. Placed inside the stator's magnetic field, the rotor is pushed and pulled by magnetic forces, making it spin. Multiple coils ensure smooth, continuous rotation, no getting stuck. The shaft is supported by bearings for smooth, fast spinning. The rotor brings the motor to life, turning invisible forces into useful motion. Every spinning blade or wheel you see is thanks to the rotor's hard work. So, How does a motor actually spin? It's all about magnetism. Opposites attract, likes repel. In a simple DC motor, the stator's magnets create a field. When the rotor's coil is powered, it becomes an electromagnet. The rotor's north pole is repelled by the stator's north and attracted to the south, making it turn. But if it stopped there, the motor would freeze. Enter the commutator. Just as the rotor lines up, the commutator flips the current, reversing the rotor's poles. Now the rotor is repelled again, forced to keep spinning. This flip happens hundreds or thousands of times per second, creating smooth, continuous motion. It's a magnetic game of tag that never ends. The result, reliable, powerful spinning that powers everything from fans to cars. All thanks to clever engineering and the simple rules of magnetism. That's the secret behind every electric motor's spin. Now that you know how motors work, you'll spot them everywhere. They're the hidden heroes in your daily life, powering countless devices. Your electric toothbrush, a tiny DC motor, your blender or coffee grinder, AC motors at work, even your computer's hard drive uses a precision BLDC motor. Household chores, washing machines, vacuums, and refrigerators all rely on motors. Motors have revolutionized transportation too. Electric vehicles use powerful motors for quiet, clean driving. Trains, subways, and trams have run on electric motors for over a century. Even airplanes use small motors for flaps and systems. Electric motors truly drive our modern world. Next time you use a gadget, remember the motor working behind the scenes. Electric motors aren't just useful, they're full of surprises. Did you know a motor can work in reverse as a generator? That's how electric cars recharge with regenerative braking. The smallest motor ever made is just 16 atoms wide, visible only with a powerful microscope. Some motors spin at over 100,000 revolutions per minute, much faster than a race car engine. Electric motors are incredibly efficient, converting over 90% of electricity into motion. By comparison, gasoline engines waste most of their energy as heat. That's why electric vehicles are so efficient and eco-friendly. Motors are getting smaller, faster, and smarter every year. The future of electric motors is just as exciting as their past. Let's review what you've learned about electric motors. First, what are the two main parts? The stator, stationary, and the rotor, rotating, working together with magnetic forces. Next, what rule of magnetism makes a motor spin? Opposites attract, likes repel, creating the push and pull that turns the rotor. Can you name a device with an AC motor? How about a DC motor? AC washing machine or fan? DC electric toothbrush or remote-controlled car? Understanding these basics helps you recognize motors everywhere. You've completed your beginner's guide to electric motors. Now, when you see a drone fly or feel your phone vibrate, you'll know what's happening inside. The dance of electricity and magnetism powers our world. Stay curious and keep exploring how things work. The story of electric motors and your curiosity never ends.